we'll go ahead and get started with some soybean nutrient management updates, a little bit of agronomic management updates. So we presented on this last year. We have 2 years of data now. The Delaware Soybean Board has funded a project on soybean planting timing, so that we can look if we can plant at earlier dates and if it's going to affect yield. It's very popular across the country. There's a lot of states that have seen benefits. If the weather turns out right and you have good conditions, planting earlier, having that longer growing season, letting your beans develop more leaves before they go to pods helps feed the crop. So there have been benefits. And so we wanted to look at, at least in Delaware, how well this was doing. This year, we actually, University of Maryland joined us, and I should put Nicole Fiorellino on here. She added sites across Maryland. I have not seen the yields on that. So the first year was just Delaware, but this last year, there should be 3 sites headed across Maryland, so we can get a regional view and not just what's going on our soil types. Because we have sandy soils where we irrigate at Cargill. So you can have issues with germination and disease, and you'll see a little bit of that this year. In terms of germination, we did have some issues this year. We wanted to plant 3 different times, about 2 weeks apart each time. We did not include a seed treatment because we wanted a worst case scenario. So for the most part, you guys might not have some of these disease issues that we would, but we want to know, we want to see if it happens. If you have a seed treatment and it actually works in preventing it, we don't know if that could be an issue. So we don't have a seed treatment in this one. But we also, because I like to look at leaf tissue and nutrient uptake, if you plant these crops at different time, especially consider organic matter breakdown and nutrient release, is there a difference in the nutrient uptake in these plants? So here are the yields. Here's the ones we showed you last year plus this year. So you can see here's an image of last year's project, but here's our earlier planted beans and here's our late planted beans. We had 3 timings in here, randomized across this field and replicated. So 2020 was our first year of COVID. This was right after it started. And of course, the university had a lot of restrictions on us. Weren't sure how this was going to spread, so we weren't allowed to plant as early as we wanted. We had planned on April. We were able to get something out May 8th, May 21st, and June 4th. So not really a early planting, but it was a timing study. We had 74, 75, or 76, about 72 bushels, no statistical differences. When we say no statistical differences, sometimes all that means is they were either all the same, is saying that it can't find a difference between these treatments using math, using stats, or there was such variability in this field that it masks differences. That maybe if, say, there was some slug damage in one of the fields that lowered the yield in that, then it messes up the treatments. In this case, I really think we just didn't see any differences. 2021, the same thing. We had about 20 bushels lower. The field was right next door. So we're here in 2020, 2021, we were across this little road here on this side. So not that far apart, irrigated well during the season. We were able to actually get in when we wanted to this year. So we started April 12th, then the 28th, and then May 10th. So we had a good earlier planting study, but 25 bushels lower overall, but still no statistical differences. You can see it says, plant in May 10th, that we had 3 more bushels on average, but the stat says we can't prove that that's real. That's all it means. It might be real. It might have been better to plant later. You're going to see some of the things that might have happened in the field. Go back here. I like to use, we have drones that we can use to fly these fields. We don't do anything. It sounds fancier than it is. We take images of these fields and it basically tells us how green they are. That's what we're doing. We're just cutting out the plots and it's giving us a number that says how green is the field. And that's all this number means here. It's just a value that says how green it is. So in 2020, again, we planted May 8th, the 21st, and then June 4th. What this says is that June 22nd, early in the season, we had more growth with earlier planting, and it makes sense. It gets started, so it branches out and it spreads better, and you get ground coverage. It blocks out the soil. You have green leaves. Same thing, August 25th. It carried through the season, and what's really interesting is when you look, By the time the end of the season, the highest value was the latest planting. So you plant later, it stays green longer, and you can see that in October that these start drying down in the order you'd expect. So planting May 8th, May 21st, not much difference in what the drone saw. The same thing with the yields. Definitely had a little bit less coverage. If you look at these values, this is where you can tell that stats are pretty interesting, because before you saw that we couldn't tell the difference between 3 bushels. But if you look at this value here, 0.9545, 0.9534. So stats can find a difference in very small values if it's there. So it definitely worked in this case. So basically, it looks like the later planting in June, we didn't see a yield difference, but it did lag behind. It had a little less growth throughout the whole season. It never seemed to catch up, even though it was very small and you couldn't see it with your eye. The drone picked it up. And then it also is going to dry down later. Kind of things we already knew, but it's being backed up with the drone data. Here's the 2021 data. I have a few more dates added in here. So you can see April 27th early on, our April 12th planting, very small difference, but it sees it. It can see it greening up. By the time you get to May 23rd, both plantings are in there. They're a little higher than the May planting. But what's interesting is when you get to June, the earliest planting starts lagging behind. So we had a different issue this year, and you can see it in this image. It downs specific rows in our April 12th planting. We actually had poor seed germination and emergence, and it was down specific rows with our planter. We have a little 4-row planter that we used for this. So what we think happened was maybe one of the row units was going in a little too deep, but these seeds weren't treated. We planted in April, so we did have an issue this year. It didn't come out in the yield. The yields were all similar. So soybean is elastic. It can branch out and cover some of this and make up for the space. But it does show up in June, and it never catches up. So this is the opposite of what we saw when we got in earlier. This earlier planting was always behind. It could never quite cover the ground like the later plantings did. So what's interesting to think about in that is what kind of effects is that having? If you're not covering the ground as much, is it allowing light in for more weed growth? Is it allowing light in to dry out the soil faster and reduce soil moisture, particularly if you're not irrigated? I can't comment on that, but it definitely seems a possibility. And then it actually, even though it was behind the whole season, it dries down faster. It loses leaves because it doesn't have the ground coverage. So this is the same. These are the drone measurements across the season. So what you can see here, you see this drop off in NDVI. Well, that's because, like Mark was talking about earlier, in terms of controlling weeds, we had to come back in here. Our pre-plant didn't catch everything. We had to come back in, and you actually see a drop in that greenness because we're killing weeds out of the field. And then you get this really rapid growth from June to July, and then it plateaus out. But right here, this blue dot, that's your April 12th. You can see that the earliest planting this year was only green at the very beginning, and then everything else, you can see the separation where we didn't get good emergence, that the later plantings did a lot better, and they held on longer, and this early planting really just didn't have ground coverage even through September. So the drop in early NDVI is weed kill. We had that rapid growth that you can see in June to July, and then early April planting just never caught up this year. So this is a reason you do multiple year studies. What is good to point out, though, is you can see that it was always a little bit behind in its coverage. The drone says, yeah, it's not growing quite as well, but there was no difference in yield. So the question is if we hadn't had this issue, if we'd actually had the soybeans planted correctly and they emerged well, maybe we had the seed treatment on there, would it have yielded better then if we actually got the germination? So poor germination probably lowered the yield. I can't really say whether we would have had better yields or higher yields, or it would have stayed even statistically, but it's definitely possible. We are still waiting on the data from 2021, but this is last year's nutrient uptake data. I showed it last year, but I still think it's interesting, just as a reminder of what happened. By planting later, I didn't actually think we'd see some of these results, but the soybeans planted in June actually took up more phosphorus. The soybeans planted early and mid-May took up more calcium and magnesium. I can't say why. The study wasn't set up to look at that, but Something happened. Was there more sulfur available earlier in the season? And did that help with potassium uptake? Was there more potassium available? Did it move out? Did it leach? Was it not available? Did weeds take it up? It could be a number of reasons why this occurred, or was it a response within the plant? Same thing. We get these micronutrients taken up in higher amounts early in the season and not later in the season. So remember, in 2021, we're going to have April, and May in here, and we might see different results, or there might be no difference. So it is interesting to think about when we're looking at nutrient recommendations and taking those leaf samples, say at about R2, and what you'd expect to be in the plant, and that planting timing did affect what nutrients were taken up that year. So it's something to take into consideration. So in summary of the timing study, we've got 2 years. We're hoping to do a 3rd year. Study sponsored by the Delaware Soybean Board. No differences in yield in 2020 or 2021. So you could plant anywhere from April to mid-May this year, and we wouldn't have seen a difference. Every field's different, every environment, the weather, your seed treatment, all that would be different. We didn't see a difference. And DVI did measure lagging growth from the early plantings because we lost some of those seeds. And nutrient uptake, again, this is what's most interesting to me, is we do have a difference in nutrient uptake. Another study that we had on cover crops and nutrient cycling, we had 3 years of this. 3 years of this study just completed. We did soybeans and corn. It's funded by the Delaware NRCS, but we're just going to talk about the soybeans in this study. And the question was, how much annual clover or vetch add to the soil and mix with rye? So it's certainly for corn, we're interested in that. But if you there's the thing about legumes preceding soybean. Is it going to introduce disease? Is that nitrogen possibly going to reduce nodulation? We don't know some of that. And so we also included soybeans in this study, and we also did a later termination. So we terminated 2 weeks ahead of planting, and then planting green and terminated later. So would it affect the emergence? Would it affect the nitrogen that built up in there? So we've got 3 years of this study, 4 treatments and 2 crops, no cover crop. You can't see it in this image, but rye mixed with vetch and rye mixed with clover. So introducing that legume to add some nitrogen. We planted, terminated 2 weeks, and then at planting, and we did it at Georgetown, irrigated sandy soil, and then Middletown, finer textured, not irrigated soil. So in 2019, still not sure why, a very odd result that we actually had 17 bushel advantage by mixing rye with vetch for soybeans. 17 bushels is a big advantage in soybean growth. It only happened this year. It happened in this field. We never repeated again in the 2 other years that we did it. You can see in here that we did have some sudden death syndrome. That Alyssa mentioned some of that, and we actually were able to plant earlier in this field, and it had SDS in it. No effective termination on soybeans. Middletown was also interesting. The yields up here were only about 30 bushels. It wasn't great. It was a dry year. The clover mixer rye alone increased yields by 5 bushels, but no termination effect. So our idea in Middletown in 2019 was that we had a really dry period in the summer, and that it's possible, and you could see it even in the corn, that the mulch layer, as small as it was from these cover crops, helped hold on to some moisture. We did not have moisture sensors, so I can't prove that. 2020 for soybeans, we had no yield differences by cover crop. So we had 17 bushel advantage of mixing rye with vetch, nothing the second year. This is why you do things multiple years. Yields range from about 49 to 55 bushels, no termination timing effects, just no effects in Georgetown. Irrigated soil might make up for any differences in the cover crop. Middletown, so this year, Middletown, we actually doubled our yields there, 60 to 67, because we had adequate rainfall and it was timed really well. Obviously, you can't control that, but so then the cover crops had no effect, but terminating early there, 2 weeks ahead of time, had a 7 bushel advantage. That was statistically significant. So in a year with adequate rainfall, Middletown soils preferred to have 2 weeks ahead of time on soybeans. Georgetown soybeans in 2021, same thing as 2020, no differences. Cover crops had no effect. Termination timing had no effect. So that 17 bushel advantage the first year seems like some kind of fluke. We haven't been able to repeat it. And yields were a little lower. Even with the irrigation, we only had 33 to 47 bushels. We had some disease in this field, just like the other year, that might have brought down the yields. Middletown, no termination effect. Didn't matter when you terminated, but now rye had the highest yields, followed by mixes with clover and vetch. And what's going to get important here in a second is talk about how much biomass was produced, because you can produce a lot of biomass in Sussex County compared to Newcastle. It's warmer, and we tend to have, we can plant earlier, and the cover crop produces a greater biomass. So even though these studies might seem similar, we typically had a little bit less biomass in Middletown than we did in Georgetown. And there's another important thing about which one of these might have worked the best. So when we say cover crop biomass, we come out here with this little square right in here. You can see it. And we clip out and weigh how much cover crop was there before we terminate it. And then we send it off to look at nitrogen analysis too. So no cover, we even clip the weeds. You can see that there's plants in the no cover plots. There's weeds in there that are adding up some biomass, but nothing. You got almost 7 times more in Georgetown, our highest value, by having clover mixed in there. And what's interesting is we often talk about rye as this biomass builder, and we don't talk about legumes as much, but that's in maybe a corn situation when you plant in April. The longer you wait, when we wait on soybeans, you can see how much biomass you build up here. Adding a legume really added to the biomass. When Mark was talking about weed suppression, the later it's particularly for soybeans, if you wait to 2 weeks before, you wait into May, you can definitely build up biomass. And that year they made us wait due to COVID in 2020, we had 17 megagrams. That's a lot of biomass for cover crops. When we look at studies across the country, this is as much as Florida is getting in their warm environments. It's a very high amount. It's hard to get this. You have to wait to build this up. So you can see it's clover does a great job, except in Middletown as well. Middletown clover, vetch looks like it has a lot, but clover has the biomass. Vetch has the nitrogen, but clover has the biomass. So there are obviously, there's planting concerns with biomass. We saw it in one year. So the later you wait, you have to plant into this. So you have to make sure you have your planter settings right. The first year, whatever planter we used worked really well. We had a different planter the other 2 years, and we had emergence issues with soybeans. Planting late didn't hurt stands in 2020, but not yields at Georgetown. So we had a stand issue because of that 17 megagrams. So yeah, it's exciting to have that much biomass, but it did cause a planting issue for soybeans, not for corn, because we were in there early enough. So making sure you're getting out and checking your planter settings and getting that ground is important. And every year in Carville only in Georgetown, we had disease issues in this study in soybeans every year, and it was a little different, and we don't know why, and it didn't follow cover crops, but it was in these fields. It didn't happen in Middletown. So I can't necessarily say it was this project, but it happened, and disease was an issue with having the biomass there. So this is an image of rye. Over the season, we put these bags out. Some of you might have been a part of this study, and this is a different study, but you look at this rye biomass. It's headed out. So this is a late kill on this cover crop. And this is from termination to harvest, how much it breaks down. This is how much it's lost over the season. It's an irrigated field of warm weather. It's going to break down, but you do have some residue left when you get into October, November. And now a lot of that's related to C to N ratio. If this were a clover, there's probably very little left. And it comes down to that C to N that we talked about in the corn session. If your C to N is less than 20, which a lot of legumes are going to be, then you're going to break down a lot quicker versus this rye. So you look at this rye, 40 to 57. It's not breaking down very easy. That doesn't mean it doesn't break down, but it might mean that it's stealing your nitrogen. Whereas when you mix in vetch, although vetch didn't have the highest biomass, it has the lowest C to N because there's a lot of nitrogen in vetch. So there is a benefit. The reason these Middletown values are so poor is because the legumes don't grow as well up there. So you have to pay attention. It's not just that C to N, but how much of that plant was in there. So the total nitrogen becomes important. So although clover was very important in its biomass, maybe for weed suppression. If you're looking for nitrogen, it was in the vetch. So even if vetch had slightly lower biomass, plant growth, it has a higher nitrogen content, and it usually comes out as one of the top ones, except Middletown was pretty even in that second year of the study. So the overall take for soybeans with cover crops is we didn't see a benefit, but it didn't really hurt yields either. We didn't have a real problem with it going through. So sometimes cover crops increased yields. And I think if you're talking Middletown, if you have a dryland field or rain-fed field, then if you have a dryland field, then maybe it helps preserve moisture, but you have to build that biomass to do that. You'd have to have a later kill and build up more biomass. Letting cover crops grow longer and accumulate biomass does not appear to decrease soybean yields across Delaware in this study. But planting issues can occur. They can reduce stands. You can have disease issues. You can have slug issues, as David was talking about. So it's hard to manage, but we haven't seen a major issue with using cover crops. So the last thing that I'm going to talk about is mapping soil types and soybean responses, which there's doing all these studies and plot level studies is useful. But a lot of the variability that you guys see in your larger fields is coming from things that are harder to control, like your soil type and your drainage issues and things that you can't see that you can see with remote sensing methods like this drone image. And you can see that we set up plots in some of our fields, and walking this, you can't see it very well. But when you take a look at this image, I've shown it before, but very obvious soil pattern going across here. Across both of these sections, there are things going on in this field that are beyond our control and beyond our treatments. And mapping these responses could provide a guide to higher yields, and especially if you've listened to some of Mark's points about where are you going to put out, where are you going to save your Roundup for? If you have a limited amount or it's costly, where are you going to go out and do that? And the same thing with where you're going to put your seeds, where you can put your nutrients. It's the most responsive part of your field is typically where you would do something like that. So being able to map and look at your field variability can help, especially when we have higher costs. You can start to maybe focus in on, are there more responsive parts of the field that I can focus on to get my yield back, and the parts of the field that I'm wasting nutrients on that aren't going to yield, I can cut back on that. So soil maps are great at a general view of what's going on across your field. So this is Warrington, our research farm. I like to show this one because we have more data on it. So you can see these soil types. It kind of crosses over the center of our irrigation pivot, and there's a different soil type over here that they've mapped. But people use these in research. They use these to describe possibly where yield differences might be, but they weren't mapped for that. These fields were mapped. They might do 300 acres in a day. It was meant as a general guideline for the public to, if you're going to purchase the land, if you're thinking about where you're going to put septic, it was meant as an overall field view. It was not meant for precision agriculture. It's useful, but it wasn't meant to make precise types of recommendations. You don't throw it out. You don't ignore it, but you use it. You use the description of the soil type and match it up with other data to get an idea of what's going on across your field. So it's not really enough. To me, it can be accurate. We've seen some fields, I think, in Wicomico County, when we did some mapping, some EC mapping, the soils matched up very well in that case, but they don't in all cases. You're going to see in this image how it doesn't pick up everything. So when you're going to do field sampling, there's a question of how variable your soils are, and you might have several different soils going on across one field, or you might have all one soil type, and that's going to affect the yield response that you have across there and the decisions that you're going to make, as well as how many soil samples do you take, and can you describe this, and what's the cost of trying to figure out these variabilities in soil types. So this is one field and this is possibly only going a couple hundred feet. You can go from well drained, you see these red orange colors, you dig down there, even if it's wet, you see orange colors, that's well drained. When you get down and start seeing grayer colors, like in this soil, then you know that you're getting a poor drained part of the field. So we have plenty of organic matter sitting up here, and it looks like you have plenty of organic matter here, but this is a wet soil. These gray colors, gray and orange together, tell me that it's wet. So you're going to have different responses. You know, in a dry year, this might be your best part of the field. But in a wet year, it's like in 2018, you remember the flooding in the ponds we had across this region. This is going to be the worst part of your field. So even in the same field, they might map this as all the same soil type because it was easier, but it's gonna exist across there and you're not gonna see it. One of the easiest ways to see your soil types, and you can do this on your cell phone, you can do it on your computer right now, as I like, this one's user-friendly. Web Soil Survey is, I think, a little more professional. UC Davis, University of California, Davis Soil Web is the easiest way to see your soils. You can actually walk out in your field, pull this up on your cell phone, zoom to your location, and then pick up your soil types. And it'll tell you what's underneath your feet. And that's why I like it. All kinds of information without even digging down. It can kind of give you a guess of what your soil profile might look like. You see those gray colors? Well, it's Othello. We know that's a wet soil. It can give you estimates on your clay and sand content, things like that. So I find it to be very useful. But soil maps don't show all your variability. So this is our research farm. Here's where the soybean trials were. Here's where Amy Shover's HAP study, or high available phosphorus study. So this is a lot of where our research is. Here's that image that's showing you these differences. And here's the field. It's all mapped as one soil type. So it's not picking up these differences. Not necessarily that this might be small enough that you can't really manage it differently, but in larger fields, you might be able to. But there's still a difference in the response of that crop to this. So these maps are great at a general guideline of this entire area, but not on site-specific management. What's interesting is when you actually look up the old paper survey, somebody did have a different soil type in here, but it was at one point, for whatever reason, whoever reclassified the soil removed that, even though it does kind of show up in here that they saw something a little bit different. And here's an NDVI drone image, and you can see it picked up some. This is 2018, so this was a drowned out spot. This is actually weed growth. So yes, they picked up this section pretty well, but they didn't pick up all this variability. And you might not necessarily see, there's a lot of differences in soil across this field that we're not picking up. And another thing soil maps don't pick up is past management. So here you can see some manure application, and here's some overlap. So you're going to have a higher amount of nutrients, and then you've got a lower amount right in here. And this is actually a grid sampled field that shows high phosphorus down here and low phosphorus up here, and a lot of potassium maybe around the old barn where they were just hauling manure out, a lot of potassium right around the edge here. Maybe the cattle accumulate here, I don't know, but there's high potassium here, high phosphorus down here. You can't see this on a soil map, and you can't see this if you take one soil sample across here. You have to actually go out and take all these individual samples and pick up, because the potassium up here, you might not need to apply it versus down in these areas if you're going to grow some corn. Same thing with phosphorus. You don't need phosphorus down here, but you definitely need it up in this part of the field. So there's some other, particularly in Delmarva, there's some other layers that are very helpful. So again, here is Warrington, and you're going to see some of this pop up. So this is an elevation layer. So remember that our soil layer cut across like this. But now we can see these very slight changes in elevation, and it only takes 6 inches, a foot, a couple feet, and you can have a water hole in a field, and you can have a wetter spot. We just have very gentle topography on Delmarva, so it's not very hard to have water pond up there. So elevation can be useful even if you can't see it. And so here's elevation across our soil maps. It's picking it up a little bit. You can see some of that pattern across here, but it's not picking up all these differences. It's not picking up this and this section here. And this is an important one because it pops up in several images. So this is a drone image that kind of shows, you can see a little bit more of how that elevation might affect. So we have corn down here and then soybeans up here. So this is a picture from this year. And here's where you can kind of see maybe that's why it's wet across here. Maybe this is lowering yields. across this field because our elevation is a little bit lower across this than the rest of the field. But remember that image of the soil, that it had it mapped across the entire part of the field, that we had the soil cutting across like this. But our yield response is different than what that soil was mapped as, and it follows elevation a little bit better. So there are different ways that you can start to look at these soil types. And so one way is you take a sample of the whole field. That's the cheapest way to do it, and it's very efficient economically. If you're starting to if you want to find out where past management issues went on, if you want to find out different soils, you can grid sample. I'm not the biggest fan of grid sampling because sometimes it seems like a lot of work unless you're really trying to find something. If you have years and years, at this point, you should have years of yield maps. That can tell you as much about where to sample as taking grid points, especially if you've got different tissue samples. If you looked at things across the field and tried to solve problems in the past, you might know without a grid sample. So in that case, you can split a field up into zones. Well, we have this low wet spot down here. We have this upland portion that's drier, and then we have these two that are similar. So you can also do zone sampling where you know your yield is different in these spots. You know your crop response is different, and you can go across there. And you can go across there and sample that way. There's another thing that we can do. There's several machines, but because water and salts and soil texture all conduct electricity, not strongly. It's a weak conductance, but they conduct electricity. We can take equipment like this Varus here. There's also something called an EM38 you can carry by hand. And between these discs and coulters, you can actually measure conductance. So these two that are tight together are measuring in the top foot conductance. And then these that are further apart are measuring the top 3 feet of soil conductance. So if you have a difference in texture from sand to clay, this can map it. If you have difference in moisture content, it could map it. And the same thing with salts. So the problem is, you don't know what you're mapping without then taking some soil samples. So you can see there's differences and match it up to yield, but you don't necessarily know what it is until you get through it. So this is something you can do on the go, just like your yield maps. When you go across the field, you can see this as you're driving. As you're going across here, you can see the EC. So this is an old EC map. So that you can see how this is following elevation across Warrington. So we don't have this little section here, but this is a much more specific possible soil map. Again, it could be moisture. You'll see it could be salts in your field, but this is a much better image than your soil map of these differences. The question is, how much does it affect yield? And if you have a good yield map, you can actually match some of this up, and even drone imagery or satellite imagery can help pick this up. So here is on the go. So as you're driving, it's mapping EC, and you can actually look at these. This one has pH on it too, and then it has organic matter as well. So you can go across there and map your fields a little bit better. The question is, how accurate of a soil map is it? And it depends on what it's measuring. This is what we don't know about EC, and you still have to soil sample. So here is at Warrington again. This is our subsurface drip fields. So here's your shallow, here's your 1 foot, and here's your 3 foot depth in the map. And here is a drone image. And this is why I like remote sensing. This is why imagery from above, satellites, drones, airplanes, whatever you can get during the season can show you things you can't see on the ground. So here is this pass that we know exists on this research farm, old road, something like that, that affects our yields every single year, shows up in all the drone imagery, shows up in that EC map. You don't have to wait for 5 years of yields. You don't have to wait till July to get a picture of your crop. You can go out and map that field. It's a little bit, you can see it a little bit in the deep EC, but look how that deep measurement, 3 feet, says, well, there's a different soil type here overall. And when you have 3 feet of a measurement. So how much does it affect yield? Well, definitely here we have an effect. Maybe not as much down here. We're seeing other differences across this field. So it's helpful, but it depends on what it's measuring. And we don't know, unfortunately, by itself, nothing in precision ag by itself is enough. Having yields, having your soil type, if you can get an EC map, that's good. Remote sensing, the satellite imagery that's coming through now, the frequency of it is excellent. It's very good for larger fields. Research plots, it doesn't work for us, but for you guys that have 90-acre or more fields, I think that satellite imagery works really well at also picking things up. So the soil is a good place to get started. The elevation is very important for looking at water holes. And then if you can get ECA maps, if you can get mapped fields like this of your conductivity, it really adds a lot to it, I think, as well. Another thing that we do with it, a different grant that we have, an AFRI grant, is looking at salinity along coastlines. So if you guys have some fields that have salts coming in on the field, because it measures conductivity, and salts in water in the soil are going to, remember, they're soluble. That's when we talk about CEC. Your soil has a negative charge. Calcium, magnesium, potassium have a positive charge, so they're attracted and bond to each other, so they also conduct electricity. So that's why clay shows up differently with an EC map. The higher clay in your soil should conduct more electricity. You still have to go sample and say, well, is it clay? Is it sand? Is it water? Is it salts? And in this case, you can see along this coastline and along these ditches that we do have higher EC. We can't say it's salts until we measure it, but we know that this kind of stuff is going on. Same thing with this drone imagery right in here. Another thing, this is a reason you combine everything together: aerial imagery, EC maps, yield maps. Right in here, this is a cover crop. It's growing very well in this section, but it's not growing very well at all where the salts are. Same thing here, low salts here, we have plant growth. High salts here, we don't have as much plant growth. So all this together really helps. And I think that although most of the satellite imagery you get, it might be coming through an app and you just get to look at it, you might not be able to include it or add it into, say, if you're using SMS or something like that to analyze. It gives you a visual image that maybe you're going out and taking a tissue sample, but you can see how well this drone imagery. So here's our EC, and our yield map would look a little bit like this across here too, but the drone imagery picks up a lot. These squares here, you can see where James has turned off his irrigation. So this is 2020, and you're looking at corn on the north half and soybeans on the southern half. You see the southern half, that doesn't always have a lot of difference, but both corn and soybeans have struggled with this section across this field where we have some research trials. But I think it's really interesting to see how much you can pick up these differences if you can do these kind of studies. If like we can, you can shut off this irrigation, you can pick up soil type versus moisture content across here, and some more of these trials that go over here. So all of this information together is better than just having the soil map by itself. So here is some yield data that we have from Warrington, and you can see a little bit of these spots that go across here, but it's not as clear when you pull out some of this yield data, especially when you have irrigation that can overcome some of these differences. Here's another keyword: yield. So as you come across these different fields, 2005, 2008, different yield differences, different season, different management, different fertility. Typically for yield, you want at least 3 years of yield data so you can capture that weather variability, because the soil type differences don't matter if there's no differences in yield. So you can see that this year we don't have that pattern across here as much. So when do you see that pattern, and is it important to yield? You can see the stuff in the drone imagery, but if your yield map's the same across here, then those effects don't matter as much. And all that has to be taken into consideration. One piece of information by itself isn't good enough. So when trying to get better at mapping our soil variability, and in my opinion, from just a few years I've been here and trying to do these different fertility studies and looking at all the data that Corey's had in the past at Warrington, and he's done a lot of fertility studies of trying to get nutrients into these plants, and the differences in our soil types sometimes overwhelm our treatments. And so starting to understand how this variability in your field is affecting yield can help you make decisions, especially this year where we're looking at higher costs. This part of the field that never yields very well, if it's large enough that you can separate it out, you shouldn't put, you definitely, if you say you're growing corn here, if you're only going to pull 150 off this versus 250 on the other parts of the field, you shouldn't invest as much nutrients in it, or lower your seeding rate, or different decisions like that you can work with your agronomist on. So you can make those kind of decisions if you have the information, but you have to collect it and you have to look at it. If you're collecting yield maps and not looking at those differences and then trying to figure out why did it yield higher or lower, then it's not going to be useful to you. But all this information together, I think, has to be used if we're going to look at how soil variability is matching up to differences in weather and differences in management, and how we can improve yields by managing our soils better, especially with this push for soil health and cover crops, and how does all of this tie together to build better yields.